Hi everyone. Moving on to the cryptography. This is also a theoretical subject where we can talk more about how to secure and how to encrypt and keep our data securely on all the three states of data: data at rest, data on transit, and data at use. Okay. And objective for today, it's we understand the cryptography and what is a crypto system. And also we'll be learning more about the algorithms we use in the cryptography, the cryptographic basics. So cryptographic basics are these are giving you the key terms and the keywords which we need to remember or memorize. And most often when you talk something about cryptography, you need to understand the words. Plain text. Plain text is simply anything, whatever you type on a screen. Okay, I'm taking you to a web page which is freely available, and you can also use the link. There are multiple tools which are freely available for encrypting and decrypting your data, but any data which is uploaded to public website or public portal, that will not be secure until it's a free service. Any hosting or any service provider who is hosting a service absolutely for a free, that will not be happening without a personal gain. If I'm hosting a site, if I'm hosting a service for you absolutely free of cost, obviously I need something from you. When you enter your resume, simple example, you'll be using a PDF editor, online PDF editor, similar to like. Okay, similarly, I'm not just blaming sejjar.com or any other port. I'm just giving an example. If you upload something personally, I mean, same example, you're converting your resume or editing your payslip or anything, any sensitive document, when you upload here and edit online, there is obvious chance of having the information stored on the remote server, and that can be used on any way. Even if a hacker is able to attack, multiple software companies or multiple website are being compromised, getting hacked, there is no way to keep us say 100% secure. So please do not use any publicly available services for any sensitive documents, and just for experimenting things or just for learning purpose, or if it's not sensitive enough, you can always move on. But I would suggest always you keep best practice. So learning deeper into cybersecurity is not only just reading the articles or going through the books that will not be obviously helping you. So whenever and wherever it's possible, please try to get your hands on the tools or the technology. So we need to work on it. So that's where we can enhance the skills on a particular thing we are on it. So this is a screen, a free tool called codebeautify.org, wherein we can practically see how the plain text works. Okay. Uh, on the top, you can see there's the algorithms and the modes. Let me explain you what the stream cipher, cipher, blockchains. But let us understand the algorithm. Algorithm is simply we can relate it to mathematics. Actually, to be frank, cryptography works in mathematics principle. So there are formulas for converting the plain text into a encrypted text that's mathematically created. So when we enter a string, for example, use an algorithm blowfish. This is a demo text. Okay. So now I have entered, this is a plain text, clearly available. So anybody can read. So what are we doing is we'll be giving a key. What is a key? Key is something for locking anything. I mean locking. Everybody have a lock at their home. We use a personal safety lock which has a key. So similar to that, you can think it's a key which can be numbers, characters, or alphanumeric. What size you can have it. So for this demo class, I'll be giving the key as test 1. Okay. I'm going to encrypt the text with the key test 1 encrypt. So do you see that? It changed. Okay. What I can show you is I can copy this and paste it here because this is the output what we got from after encrypting. So now what I'm going to do is I'll be encrypting the same text with a different key. So do you see both the encrypted text differs? The first string on the notepad, which starts with uppercase J, U, C, or X, it's completely different from the string which is on the second row. The first one, we encrypted the text using a key, test number 1. And the second one, we encrypted with the key, test number 2. Okay, this is the difference. So let us see what happens when we use a wrong key to decrypt. So right now, I'll be giving a different one. So I'll just give test 3. Let us see what happens when we try to decrypt. Decrypt. Do you see what comes as a result after decryption? It's gibberish. It's useless. And it's not even readable. Okay. But we try to encrypt. This is a demo text with test 3. We'll be getting a different option. So let us copy the first one. Copy the first string which was encrypted using test 1. Test 1. That encrypted text which is encrypted with test 1 as the key, and we are trying to decrypt as with the key test number 3. Decrypt. Now this did not help us. We go with the try with the test 2 key and try to decrypt. Oh, again we missed it. All right. So let us come with the test 1. Do you see that? This is a demo text. So the algorithms plays a major role. Okay. We have successfully decrypted the text from the encrypted text using the key, but we also look up with the different algorithm. All right. What happens? We're not able to break in. Let us try with a different algorithm. Okay. So we tried with a different algorithm. Even we have the right key to decrypt the document, but we don't know the algorithm, how to decrypt. So this is also a reason why we are getting a gibberish text and unreadable format. Only when we encrypt the text using blowfish algorithm. So right, when we click on decrypt, when the algorithm and the key matches, we'll be getting the original text, what we need to. So now hopefully you'll be understanding what is a plain text, and plain text is simply words which we type in, which was understandable. And the cipher text, this is called the cipher text, which is unable to readable, both human as well as the machines. Why I'm saying even machines? The machine language is completely different. Computer can understand anything and everything which are sent as a zeros and ones. And computer can read ASCII, but human cannot read and understand ASCII, and humans cannot read and understand hexadecimal codes. But when a computer is able to understand hex, computer able to understand binary, computer able to understand ASCII, is it easy for human make use of the computer, get it translated back? When the computer understands it, it can easily convert the same thing which is understandable to humans. So the encrypted text which cannot be understood by machines as well as humans. So this is the major concept. And the cipher, plain text is simple words, and cipher text is what the outcome of the encryption. And the term cipher is the process of converting normal text to the encrypted one. And the key, we obviously understood what is a key. Key is simply like a password, or it can be a security, or it can be a key pair. And the word encipher, it's nothing but encryption. The process of converting or process of encrypting is just a enciphering. We call it as enciphering. Even most people will not use the word encipher. Everyone will be using encryption. That's more common than enciphering. So deciphering, it's called decrypting, the process of getting the ciphered text back to the original state, converting the encrypted text to the original state. Cryptography, it's a vast subject that studies about the methods of securing data using encryption. And cryptanalysis. What is cryptanalysis? Cryptanalysis is also a study wherein the researcher or the scholar or the hacker, they'll be trying to find out the weakness in the cryptographic system. They are the person who actively involving on cryptography expert or a mathematician or a software architect or engineer, they can create a crypto system. But the cryptanalysis is the study, and cryptanalyst is the person who tries to break into the cryptographic algorithm, trying to break the code, trying to break the algorithm, and trying to decipher the encrypted one. That is the person. And cryptology is a common term. It's like an umbrella, wherein under which the cryptography and cryptanalysis comes in. To be simple, cryptography is creating, and cryptanalysis is hacking, attacking, breaking. So encryption to decryption process flow. So as we already seen that, what we see a plain text. This is a readable message which goes through the process of encryption. We get the cipher text. I mean the encrypted text. And again the decryption goes. After decryption, we get the plain text, plainly readable text. Okay, anybody can read. So this is the process flow. Plain to encrypted. Encryption will give you the encrypted file. So encrypted file will be gone to the decryption process and again to the original state. What are the benefits of cryptography and why we need cryptography? It's called, we can say the data is secure. When we send some file to some person and we can show them that it's authentic. It is that integrity of the data is secure. Nobody can tamper it. Nobody can decipher it without the proper algorithm or the proper key. And it's 100% confidentiality. Without the key or without the algorithm, no one can know, open and make use of the file. It's authentic and not repudiated. In this example, what happens? There is a code from the guy in the left who has the key number 1578. This is a secret code. When we enter a secret code, we'll be getting a free coffee. That's wonderful, right? A free coffee with the code of 1578. In the scenario, there is a person sitting in the middle who's watching the traffic flows between the person from the left to the person from the right. So what happens when he tries to tap into the or try to intercept? He would not be obviously do it. Why so? Because the text is encrypted and he does not have the key or he does not know what is the message actually. So the message passed from the left to the right person, and look how happy he is. He got the right key and he is going for a coffee in the morning. This is cryptanalysis. What happens now? The person from the left is sending the same key 1578 to the person to the right, and the person in the middle is a hacker. A hacker in the cryptographic world has another name, cryptanalysis. Look, haha, your encryption key was weak and I cracked it without a key. The message is no more secret and I have the free coffee of me. So that's really sounds bad and so sad to see the person on the right where he does not have a free coffee. This happens in the real life scenario. So when the key and the algorithm is not strong enough, obviously the cryptanalyst will break it. So we somehow understood what cryptography and how it works, and we had an overview on how to do that. What is a crypto system? We are talking about symmetric key crypto system. There are two different types of crypto system. One is a symmetric key and other one is a asymmetric key. In symmetric key crypto system, we'll be using only one key for locking and unlocking. To be frank, the same key for encrypting and the same key for decrypting. Encryption, decryption uses the same key and no change in it. On the same example, we'll be using a plain text and we locking the text with the same key and using the same key for decryption. The types of crypto system, the same key used for encryption and decryption. Asymmetric encryption uses different keys for encryption and decryption of the data. You can also call the asymmetric encryption as public key encryption. Symmetric encryption, that's a private key encryption. We can call it as a private key that will be known only to the owner or to the intended recipient. So if I want to share some information to, for example, Ram Swaroop, only I and Ram Swaroop know the key to decrypt the data. After reading it, he'll be encrypting the data to me and send it across, and I'll use the same key to decrypt it back. So this example we already seen in live how it goes. The plain text, the key is shared with the person A and the person B. It goes through the algorithm and it's converting to a cipher text. Plain text encryption, encrypted text. So decryption, back to the original state. But they're using the same key. Sender and the receiver using the same key. Now we see what are the requirements for a symmetric encryption, that is a private key encryption. The encryption algorithm should be strong enough. So any leakage of the key, if someone wrongly shared the key to someone else, is simply like a password sharing. You are encrypting your zip file using a password. You are giving the password to your friend to decompress or decrypt. But what happens when the key is shared with other people? Obviously, there is possibility of getting the keys shared. And also if the key length is so short or not large enough to handle, brute forcing is nothing but trying multiple password combinations or multiple passphrase combinations to trying to open or trying to decrypt. There is always a possibility of trying to mix match things and get it back to the original state. And the second topic is the secret key has to be secure and it should be known only to the sender and also to the receiver, nobody else. And also the encryption algorithm should be known to both the parties. So only with the key, the recipient cannot decrypt it as long as he knows the algorithm. And the key has to be shared securely in a secure distribution channel. How strong the cryptography components? The cryptography components, the strength of algorithm decide on the key size and how long and what is the length of the key. So let me go to a different example where we can see how the keys and how long it takes. So these are the freely available online tools. This tool will help us to create a certificate signing request. Certificates are mostly used on a asymmetric encryption cryptosystem, wherein we use a public key, which the public key used for encrypting and the private key is used for decrypting. There are two different keys. The challenges of symmetric encryption is sharing the key securely to the person. I mean, as we use the common key for both encryption and decryption, it's really hard for us to transmit the key and make them store it. And also maintaining the trust, whether the recipient will be having the key confidentially or will it be sharing to the someone else or not. So these are the main concerns arise when we try to use a symmetric encryption. Symmetric encryption algorithms, there are two types. Two types of algorithms are available. The first type of algorithm will be a block cipher. In block cipher, what happens is block ciphers usually block encrypt. If it's a block, first four blocks will be encrypted and second four blocks will be encrypted. Likewise, it encrypts block by block. First 64 bits, example. For example, we can make it as a 64-bit. The complete characters on the 64-bit will be considered as a first block. So the block will be encrypted and we consider this one as the second block. The block wise, it will be getting encrypted one by one. Whereas a stream cipher will encrypt bit by bit. Every bit will get encrypted. And we can see the popular examples of symmetric algorithms are Twofish, Serpent, AES, Blowfish, Cast5, RC4, etc. So these are the types of symmetric key encryption, which uses a single key for encrypting and same key for the decryption. Symmetric and asymmetric. Symmetric uses only one key for encryption and decryption, and asymmetric uses one key for encryption and other key for decryption. Asymmetric encryption deals with two different keys. One is a public key and other one is a private key. The beauty of asymmetric encryption, what it is, you can encrypt the text using your private key and you can decrypt the text using your public key. So you can use any keys. You can use your private key to encrypt and public key to decrypt, or public key to encrypt, private key to decrypt. So both key will be adjacent. Functionality will not make changes. If the public key is simply a certificate which is hosted on the website, and the public key is very much freely available, so anybody can encrypt a text or anybody can encrypt the data using the public key and send it to the server. The server will decrypt the encrypted data using the private key and it can read, and it will again send the packet back to the original, encrypt the data with the private key and send it back to the client, and the client can read the decrypt the data using the public key and it can use it. So the public key can be used for encryption and decryption as well. Unlike the symmetric key, it's so easy. So for it, the public key will be obviously kept secret, and it will not be shared. There is one more method of key sharing, not only with encrypting or decrypting with public and private key. There is also tokenization method. Asymmetric encryption is simply using two different keys. The encryption process where different keys for one is for encryption and the other one is for decryption. The keys are different but are mathematically related such that retrieving the plain text by Decipher, encryption can be done with one key and the decryption can be done with other key. So no major difference will happen with these keys. Okay, asymmetric key encryption. Here the plain text, it uses a public key and goes to the algorithm and it comes as a cipher text. And the cipher text uses a private key and throws to the algorithm, and now it comes back as a plain text. This is a simple difference. A plain text, encrypted text, here using the private key, decryption done, and receives the plain text. The features of public key cryptography, the benefits of public key encryption. Every user in the system needs to have a pair of different keys. A pair is always two. One is a private, another one is a public key. These keys are mathematically related. When one key is used for encryption, the other key can decrypt the cipher text back to the original state. So any key can be used for encryption and the other key can be used for decryption. It requires to put the public key in public repository and private key as well security guarded. Hence this scheme of encryption is called public key encryption. As I said before, the public key will be available for everyone around the globe. It will be hosted on a website or it can be shared to any number of people. The public key not only a certificate, it can be a string or alphanumeric character, or it's a passphrase, or simply like the notepad which I shown to you before. You can just share the key with someone else and say them this is the public key, encrypt using this. So once we receive that back, we can use it with the private key and decrypt it back. And one more salient feature is even though the public key and private key does the same job, it is impossible for anyone to identify the private key. And when a sender needs to send data to the receiver, he obtains the public key from the receiver for some repository published or encrypts the data and transmits. The receiver then uses his private key to extract the plain text. Length of the key, number of bits used for encryption is hefty, and hence the process of encryption decryption is slower as compared to the symmetric key encryption. So the symmetric key encryption is faster as we deal with only one key. So the encryption and decryption will be fast enough. So the symmetric key will be used for encryption, secure communication, video chat, audio chat. Asymmetric algorithm needs more processing power compared to a symmetric key encryption. The public key cryptosystem, demo 1. Okay, this demo is simple, and let me simply go on with it. It's a demo software. Okay, I'll download it. It's simple, smaller size file. Okay, I'll install it. I just downloaded it and installing it. Okay, I don't need the readme file. I'll just need to launch the program. This is a free software. This is a trial version. So I'll be continuing the trial. So Steganography method is nothing but hiding something inside a document or image or audio file, video file, MPEG file. The steganography is simply hiding something inside something. Okay, let me add a file. I'm using a PPT file. This is the file I need to hide. I'll select an image. Okay, I'm just downloading an image from Google. I'm selecting the image horse. So next. So I'll be entering a password. Okay, can use it. It lets me enter only 5-digit characters. Again, we have the option to select the algorithm. I'll go with the simpler blowfish here. instead of taking a long time to encrypt using RJA or AES. Okay. Okay. Again, there is an option. Simply, I'm skipping the encryption as of now. The target file, desktop. When I see on the, this is my desktop. When you see on the desktop, you see the size of the file, 1.76 megabyte. But when you see the size of the host, it's just 134 KB, kilobyte. When you open both the files, both will give the same picture and nobody notices a file is hidden inside. I'm using the same tool for unhiding the password. I'm selecting the plain text. So, okay. So now I'm opening a normal file. Carrier password, what we have. So let me go back and select the original host file. Next, next. Okay. Now, do you see that we find a PPT inside the JPEG file? So exit. Let's come back, and we are done with the demo one. So here I'll talk about the cryptography and how it works, and a simple example of cryptography. Initial days was long back when the time of Caesar. He was the person who introduced the ciphering system. Now we can call it he was the introducer. But during his time, he used a method for sharing the war strategy to his captains or to his army from one place to other. So what he does is Caesarean cipher is simply rotating the text to number of times. In this example, we have the alphabets aligned here, A, B, C, D, E, F, G, H in the line, and number 4. Okay. Here the plain text is just simply hello. And rotation 0 count is nothing. Will not be rotating with any other text. It's 0. Rotation 1. 1 what happens? We'll be replacing H with 1. H plus 1 equal to I. Okay, so it comes with I. E plus 1 equal to F. So L plus 1 equal to M. Likewise, it's increasing. So we'll be replacing character just next to it. So the rotation number 2 is H plus 2. Hij. So Ij, the J is the character, rotation number 2. Same way the rotation number 3, IJK, rotation number 4. So this is a very simple encryption they used. It's a Caesarean ciphering method, which is a simply rotation of key number of characters with the number of counts. And the columnar transposition, it's also simple. That was long back, the encryption that this was happening. In the same matrix method, the crypt, you see the characters aligned in rows and columns. The first column, CRYPT, OGR, AP, HY, okay, these are the alphabets are jumbled in rows and columns. They are simply replacing the column with row. The column COHOR, the COHOR replaced in the row. COHOR here. GYOYR, GYOYR. So ILPAS, ZTPCZ. So they are just transpositioning a row into a column. Simply, these are simple examples of how the algorithm works. The goal of the data encryption system on Symmetric, it is just fully scrambling plain text into a ciphering text. And the data encryption standard is block size, and it is not a stream variant. So everything will be encrypted in segments. So block by block, 64-bit, 128-bit. The bits are counted as a block, and they are encrypted in a block. It is the most used crypto system. So again, when we talk about the complexity, so initially we checked out the Caesarean ciphers, tabular ciphers, transpositional ciphers, and now it's an example of DS block encryption, block diagram, how the encryption would happen. So there is a 56-bit key is getting generated, a 64-bit plain text is inputted. Plain text on the round 1, it converts with the 48-bit rotation, and the round 2, it goes with the keys rotated with the 48-bit, and again a 16-bit is done. The final permitted 64-bit character. So it's completely jumbled. just like scrambling your eggs. You open up the eggs and drop it in a bowl and smash it and scramble it. You won't have anything to be a readable manner. This is an example. And in the rounds, round 1, round 2, round 6, we can call it as a mathematical formulas. All the algorithms will not be same. They have a different pattern and different rotation system or different conversation method. So the comparison between symmetric key algorithm and regular algorithms, the data encryption standard uses block cipher. We already know what is a block cipher. Block will be encrypting in blocks. The stream cipher will be every single bit will be ciphered. DES, triple DES uses a 168-bit value. Blowfish uses a value variable. That's variable. You can configure amount of bits from any number up to 448. The advanced encryption standard user also uses block cipher, which varies from 128-bit to 256-bit. And RC4 is a stream cipher. Stream cipher, every single bit is stream ciphered. So it's used for most of the SSL implementation. So now we go for the RSA. RSA is an algorithm which was named after the inventors who designed or created, we can call it as inventors. RSA stands for Rivest, Shamir, and Adelman. These are the three who involved in inventing the RSA algorithm. And it's an asymmetric algorithm. It uses a public and a private key. The key sizes vary from 512 to 2048 bits. And it's also a most popular algorithm. How the key is getting generated, it uses two prime numbers. The prime numbers is the largest divisible number by itself. For example, it takes two different largest prime numbers and it makes the computation. This just shows how the formulation of generating a public and a private key. To be simple, RSA also uses a mathematical formula which generates a public and private key. That is simple. Thank you so much for attending this session.